Hi. So I had a student email me about one of the sheets that I gave to my Algebra 1 class. So this is an Algebra 1 video. I will one day organize my channel to have Algebra 1 and Geometry, but we'll get there. It's Monday, March 23rd, week 2 of the emergency shutdown, I guess we want to call it. So things will get organized and I will be better about it. All right, so I don't have the sheet. I can't find it at this moment, and it's really not that hard to write down. It's the one that on the top says solve a quadratic with a square root, and I'll show you what they look like. So we don't have to do all of them. We did it as a warm-up, but let me switch. Hold on, let me pause for a quick second so that I can stop sharing. Get this on the right screen. All right, sorry, I just wanted to get this to be on the right screen, my little pen. Okay, so the first question, and fast forward through all this, la la la. All right, the first question, we did this actually for a warm-up, but it says something like x squared equals 9, right? And so we want to know, the way that this is written and what this is asking is saying, what times itself? And I'm going to write that down so you can think about it. What times itself is 9, right? I'm going to say blank, and in this case, the blank is a 9. And ask yourself that every single time you see that squared there, because that's what it means. It's saying, you know, it's literally, we call it squared in English. It's literally, there's a square. So we have something times itself is 9. And what is that? Well, it would have to be 3, right? Because 3 times 3 is 9. So if x squared equals 9, then x equals 3. What we're taking is the square root, because squares and square roots are opposites. So x squared equals 9. Well, if I take the square root of x squared, right? The square root and the square are inverse functions, so they cancel each other, right? So we'd have x. The square root of 9, if we threw it in a calculator, and you absolutely can, the square root of 9 is 3, all right? There's some that you should remember. I mean, they just make your life easier to remember, but you don't have to. Perfect squares are good to know, though, so if you do a multiplication grid, anything you see like, 1 squared is 1, 2 squared is 4, 3 squared is 9, right? I'm not writing very pretty equals. 4 squared is 16. All of these are perfect squares. They're good to have in your head. They're good to know quickly. If you can do 1 to 20 squared, you're in a good spot. I'll write them all down. You can fast forward if you want to. 5 squared is 25. 6 squared is 36. Sorry that my children are here. They are. Hey, Zora, go play. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. And you get it. 11 squared, you can fast forward, 121. 12 squared is 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. Now we're really testing me. 16 squared is 256. 17 squared is 289. 18 squared is 324. Oops, messy handwriting. 19 squared is 361, and 20 squared is 400. All right, so I went all extra for that, but because we've been doing this, I'm just going to show you, right? The difference, the first difference, plus 3, plus 5, plus 7, plus 9, plus 11, plus 13, plus 15, plus 17, plus 19, etc., right? And I could keep going. My second difference is 2, plus 2, plus 2, plus 2, right? So quadratics, well, we know it's quadratic function because it's squared, right? And we've done this a bunch of times before, so that's good news. So x squared equals 3. I like that I don't have finish problems. All right, number 2 is x squared equals 25. Well, I have this handy little chart now with all this extra writing on it, but I can erase it if I want to. So if I want to know what number is 25, what number squared is 25, well, there it is right here, it's 5. We are only going to be dealing with x equals 5, because right here. We're only going to be dealing with the positive roots right now. We may get into some negative square roots, but they're imaginary, right? And that is more of an Algebra 2 topic, but it's something that we can talk about later and see how far we get this school year. So 5, the square root, we're taking the positive root, so we don't have to worry about it. So that's number 2. You know, number 3 is to say 3, x squared is 4, so what is, so x is 2, et cetera, et cetera. But I'm sure the ones that are trickier are the ones that look something like this. And I'm going to color. So we have x minus 3 squared equals 36. Right? And just like up here, we're going to take the square root of both sides. Now it can get a little bit more complicated with like, well, is the positive, the negative? Well, at this point, we're dealing with positives. Let's just focus on this first, okay? So the squares and the square roots cancel, right? So this undoes this, right? So what we're left with is x minus 3 equals, well, the square root of 36, as it is here. 6, right? We want to solve for x. Now we have a one-step equation. We can do it. We can just add 3 on both sides, and there we go. X equals 9. So you're basically, if you see that square, you're taking the square root of it. That's step 1 with that. If you have more questions why, please let me know. Basically, another way to think about it, and if I just change my color for a quick second, that this, say I said, I got back to this equation right here, and I didn't, oops, that square should be there, and this square should not. I could, you know, make something up. I could say that y is equal to x minus 3, right? This is why this works. Again, if you get it, fast forward. So if y equals x minus 3, then what this really is this is y squared equals 36. Take the square root of both sides. You know, now we don't have to deal with all those parentheses and it's not distracting us. So y equals 6. Well, if y equals 6 and y also equals x minus 3, then we can say, we can substitute. We can plug this in for this y, so that's x minus 3 equals 6. And then again, add 3 on both sides, and x equals 9. All right, let me see. I only have this much space left in it. Let me find a tricky one. Number 9 looks a little tricky. So that one is, it says that x plus 7 squared equals 1. What do we do first? Take the square root. Take the square root of both sides. So x plus 7 equals 1. X, well, I'm going to subtract 7, x equals negative 6. Now, I know I said that we're dealing with lots of positive numbers here. Yes, but doesn't mean that you can't get negative as an answer, because negative 6 plus 7 is 1, and 1 squared is 1, and that's why that works. All right, let me check out a couple more. I know that there's some, oh, okay. If you do get one that says, like number 11, x minus 5 squared equals negative 4. At this point, this does, well, it doesn't exist, and that's why we call it imaginary. But if I take the square root of this side, the square root of this side, I'm going to get x minus 5. But then what you want to ask yourself is that original question, what times itself is blank, right? Well, what times itself is negative 4? Nothing, because it's either 2 times 2, which is positive 4, or negative 2 times negative 2 is still positive 4. So at this point, I mean, it's imaginary, right? And I know that we got into philosophical conversations about numbers previously, but it's imaginary. It would be 2i, and because we have defined the root of negative 1 as I. And that's Algebra 2 stuff. So I'm not going to get too far into it, but at this point, if you see that something squared, I'm going to go back to it. If I go say something squared is negative 4, no answer, no real solutions. We can say that, and that's absolutely a true statement there. No real solutions. No real solutions. All right, you will get something called imaginary solutions. They're the unicorns of the math world, and they're wonderful and beautiful, and they have lots of functions. But if you get something here where you're squaring it and getting a negative, you're not going to do that at this point. So I hope that answers that question. We've done a few of them. There's a couple more to do, but I think that you can get them. Just take the square root of both sides. Here's a list of all your squares. Look up also multiplication grids. It's better if you do them because then you're actually showing grids. Can't talk and type at the same time. So there's these, if you look at like the images of them, I'm sure that there are some that are done, right? Oh, see, this is what I was thinking of and didn't want to say. I did not want to not say, but he's fine. We made fours. Okay, so if I look at this, right, I'm not going to print it, I'm not going to steal it, but all of these yellow ones are your perfect squares, right? So they did till 12. This is a good thing to be able to do, I think. I know you always have a calculator, but that's a good thing to be able to do. So I hope that that helped with that worksheet. Again, on the top, it is called Solve Quadratic with Square Root. That's what it is. All right. I'll try to get a couple more videos done. Hope you guys are having a good day. I'm working on my Fort skills. Hold this for me. They don't. They don't. Understand. I miss you guys. Have a good one. Bye.